Hello, everyone, and welcome to today's SANS webcast, How to Eliminate Alert Fatigue by Turbocharging SOAR with NSM, sponsored by Corelight. Today's featured speakers are Richard Baitlick, Principal Security Strategist with Corelight, Wissam Ali Ahmad, Lead Solutions Architect at Splunk, and Troy Moore, Cybersecurity Analyst at Idaho National Laboratory. And with that, I'd like to hand it over to our first presenter, Richard Baitlick.
Thank you, everyone, for joining us today. I know we've got some crazy times going on out there, so I appreciate that you took an hour of your time to talk about network security monitoring and SOAR and how those things can work together for you. There's a couple of points I just wanted to use to frame the discussion that we're going to have today. And the first one is that if you don't have good data to work with, all the expertise in the world isn't going to help you. In other words, what makes for a good analyst is good data. You take the smartest person in the world and you give them no evidence to work with. You know, imagine Sherlock Holmes with nothing but his mind. That's still pretty formidable, but he's not going to be able to solve the case. He needs evidence in order to figure out what's happening. So that's one of the tenets we're going to be looking at today is where can you get good evidence about what's going on in your environment in order to solve security challenges. Now, once you have good evidence and you have analysts and they're trying to deal with security challenges, the traditional model was you would execute some type of playbook, and maybe it wasn't called a playbook, maybe it was just called your process, your procedures, but that model does not scale with modern security load. It works to a certain extent, but it is really much smarter if you can integrate some degree of automation into your workflow. Now, you don't just want to automate an inefficient process. You want to, as we used to say at another company I worked at, you wanted to lean then digitize, which was the CIO, Gary Reiner, his main point for us. But what you want to be able to do is eventually to create playbooks that get embodied into software. So the software is executing the playbook for you, and the analyst interacts with that software when it is needed and when he or she has to make a decision about what's happening in the environment. So that's what we're going to be talking about today. We're going to be talking about how working with Corelight and Splunk can be that collection of capabilities that will give you the ability to deal with the security challenges facing the modern analyst. And so with that, I'd like to turn it over to Wissam from Splunk.
Thank you, Richard. So I'm going to be talking about how to build the next generation security operations center with the essentials of the technologies around that for analytics, automation, orchestration with Splunk and Corelight. Next. So as we know today, all of security still has challenges around security operation, and security analysts are facing with a lot of tools, right? We typically talk to customers, we hear about they have like a couple of dozens and 30 and 40, 50 even tools that they have to work with. And these tools, as you see here, they're around the gamut of different security domains, we like to call them, right? So we have proxy, firewalls, application security, cloud, right? Today you have the challenges of multi-cloud, and so on and so on. And the endpoint's still a problem now with remote work as well. So all these tools and security technologies are sending you these alerts, and you are overwhelmed as an analyst to look at what do I do with these alerts, right? So these alerts can be in the thousands, 10,000 and more a day that you have to sift through. So at the core of that solution for that, in order for you to sift, investigate, and monitor, and make a decision before you act on these alerts, you need essential tools as a security event, incident event management, SIM, that does the analytics for you based on all these different technologies. And then the SOAR is the action part. SOAR is the security orchestration automation response. So both SIM and SOAR are SIM is the platform to analyze that data emitted from all these security domains. And then SOAR is the technology and the platform to help you act on that in an automated, orchestrated fashion. So let's talk next about how is that, the framework around that. So we like to put those framework around the life cycle of a SOC, basically, typically from observation, orientation, decision-making, and then action. On the observe side is all these signals that you're seeing right now from the security domain, security tools, all the sensory data, all the network monitoring data. And what you get from those sensors is that now you need a way to process them, to analyze them. And that's where you orient, is the analytics platform is important, such as SIM. After you analyze that data is actually filtered, whittled down using correlations from 10,000 alerts to a few thousands or even hundreds. And then even more decision making will help you also make decision on those few alerts that we call notable events, turn them into actionable events. And that's where now you look at from that into taking an action, which modifies sometimes the actual, make some modifications, basically mitigations into your environment. So in the next build on this is I'm showing you how today these maps, these technology maps with Corelight and Splunk. Corelight is a network security monitoring sensors. They're sending this rich data to the analytics platform. In this case, it's Splunk and Splunk Enterprise. And Splunk Enterprise Security is our SIM product. So you have all that data coming in from Corelight being analyzed in Splunk along with other data sources. And then in Splunk Phantom on the right side, that's where you're making the decision making by looking all those notable events that were already filtered. And before you take action, maybe your action could be you quarantine a device, you add a whitelist, you send an alert to the security analyst, to the admin. So that's basically the flow of how that now we can go from manual operation to fully automation and reduce incident response time with those two technologies, with the Corelight and Splunk, and also and then the SOAR platform, Splunk Phantom. Yes, so once you have the sensory data that you're from the instrumentation and network security monitoring NSM, that data is processed in Corelight. Corelight is sending that data in the form of logs, and you have a rich set of log data and event data that you're getting out of Corelight from the DNS and other protocols. And then that data gets ingested into Splunk and indexed in Splunk. And the reason for that is for the analytics, right? Splunk analyzes the information in real time and then can give you the answers that you need. So you can say things like, show me the last network sessions that are occurring within this last 5 minutes or within an hour for this device. So you can ask Splunk questions like that through the Splunk search language, and then you have the answers in the form of results or alerts that you can actually process them in another system as well. So in this case, for a full spectrum of analyzing an attack, let's say, or incident, I take that data that's ingested in Splunk. I actually have that available to be for the SOAR platform, the Splunk Phantom. Phantom is the orchestration automation engine where I can run playbooks that would individual steps in those playbooks, we call those actions, that would query Splunk back for more context. So before you make a decision on any action you like to take, any mitigative actions you want to do on the network or on the endpoint, one of the steps in those playbooks could also be a decision-making step. So that decision-making step could be condition or some logic expression. It would need maybe some extra data points. Could be more context. It could be more things coming from Corelight. So that, in this case, Phantom, as you see in the arrows here, will query back Splunk for that information to get more context on that incident steps, and make a decision on what to do next. Could be an automation step. Do I want to right away quarantine this device, or do I want to maybe send a notification to a responder to look at this issue? So basically, going through the whole cycle from event data to analytics engine to a SOAR engine is your full cycle to responding to these incidents and then reducing all the manual steps you need, and then reducing your response time, basically. Okay, let's move on to Troy. Troy's gonna give us his journey, a very nice example and success story on how you leverage these technologies in his real world solution. Go ahead, Troy.
All right, first off, I want to give a disclaimer. This story is how the process and tools at the Idaho National Laboratory, about their process and tools that they've taken over the last year to reduce alert fatigue. This is our story and is not and should not be construed as an endorsement of any company or product. Just want to put that right out there. We enjoy these products, but we are not endorsing or supporting them in any form by participating in this presentation. All right, so a little bit about me. My name's Troy Moore. I work at the Idaho National Laboratory, and I'm a contractor for the Department of Homeland Security. The last 5 years, I have spent doing a lot of time as a data admin for Splunk, which means I've been ingesting data from various sources to supply the information into the different SOCs that we have. And when I first started the job, it was a tedious, time-consuming process. We would spend months going out, grabbing all the different sources to get ourselves set up. We needed to go to the individual DNS servers so that we could actually get the response, and the request and the response. We had to go and get the web proxy logs. We'd have to go get the sys logs from Windows, from Linux, just so we could get SSH and VNC. We had to tap the Active Directory in order to get Kerberos, NTLM, RDP authentication. We had to go log in to the SMTP server and set up capturing there. Same with the FTP servers and the firewall. And it was a time-consuming process. We basically block off time and say, all right, now we're going to go work on this server. Let's get the data in, make sure we're happy with it, and then we build alerts, move on to the next one. And it took a lot of time to get the data in. Now I still work at the INL, but I'm now in a different project, and the Department of Homeland has been given the task of protecting critical infrastructure sites across the United States. So I work in a group that we partner with different critical infrastructures, pipelines, power companies, transportation companies, and we go into their networks and we set up sensors. And we get that data and we look at it for them. And the primary makeup of these sensors are, we put a Corelight sensor in to tap north, south, and east-west traffic. We put a Snort IDS sensor in there, and we send all of that information into Splunk Enterprise. One of the big things that this sensor stack, and primarily using Corelight, has given us is the ability to have a one-stop shop for all this information. As I mentioned earlier, we used to have to go in to the DNS server, to the SMTP server, the FTP server, and set up data collection for each one of those. Now with Corelight, we're able to we just put the sensor right into their network rack, tap the network data, send it into the Corelight sensor, and we now have DNS data. We have all of it that we need. We have the web proxy traffic, and this one here is a gold mine for our analysts. They love the URI field. They go and parse that apart, and they're looking for SQL injection. They're looking for cross-site scripting in there. They're looking for command line. Recently, we've been finding bash commands being sent. It is really, really cool, and it's all there. We don't have to tap into another device to get it. We're also getting a lot of your authentication logs. We don't have to be tapped into Active Directory to be able to see Kerberos authentication tickets, NTLM, RDP, SSH. All of that is available to us through the Corelight sensor. We also don't have to tap into the SMTP and FTP servers. We just grab that traffic. Corelight takes care of it for us, parses the network traffic out, gives us the proper source type, sends it to Splunk, and our analysts are able to go search it right off. And so what that has done for us, instead of having to look at dozens or more different data sources, we can just use one. We plug in that Corelight sensor and we have the same information we used to have by tapping dozens of systems. And what that's also allowed us, from the time we take off in an airplane to go to our partner site, and from the time we leave, it is approximately 1 week, and we have all the network data. We're getting alerts from them and being able to alert the customer on things that are going on in their network. This has allowed our analysts to focus on the alerts they're getting, the logs they're looking at, and creating reports for our customers instead of spending months upon months of customization and troubleshooting and things like that. So it has allowed us to be a lot more agile in setting up these network sensors. Other thing we do is, as we work with customers, it's important that you have a standard so that you can talk with one company to another company and all be talking the same thing. It's kind of like building codes for houses. Does it make the house impenetrable from falling? No, but at least you're talking the same language. And so we use the MITRE attack framework. And here are just some common tactics that are used in that attack framework. And you'll notice I've attached the source type for how we detect these things. So as I mentioned, we can see attacks on public-facing websites right there in the Corelight HTTP logs. We can see spear phishing from the SMTP logs, and the list goes on. It's really, really powerful that with just one sensor, we have the ability to see a very large array of different attacks, and we can spend our time searching for those things instead of spending our time setting up infrastructure. So we've set up our sensor stacks. So now what happens? What kind of alerts are our analysts getting? And I'm just going to give kind of an overview. Well, when we started, we had all the snort logs coming in. Corelight has its own set of notices, as they call them, but they're alerts. And then I lovingly say this because I'm not meaning to be mean or rude, but you know what? We had the good idea fairy. The good idea fairy is whatever a manager or an analyst thought would be a good search. And you know what? Most of the time, they are. But a lot of the time, they bring back a lot of false positives. The fidelity rate is not always the same, and it can just start to increase the amount of alerts you start getting into your SOC. So what is the alert fatigue that we were going through? And we followed the guideline that an analyst should have no more than 20 alerts a day. Well, we at the Idaho National Lab were overachievers, and each analyst during a certain time period had between 2,000 to 6,000 alerts daily. That's slightly higher than 20 alerts a day. And I just want to point out, I say this jokingly, but in all seriousness, received is not the same thing as resolving. We received 2,000 to 6,000 tickets. There was no way we were coming close to resolving that many tickets. And that caused a lot of concern. What are we missing? Are we missing the valuable stuff? Are we spending so much time with noise that we're actually missing the real important stuff? So we knew we needed to do something. So here's our journey. First thing we did, and I'll cover each of these 4 steps in a little more detail, but the first thing we did is we broke the alerts down into alert types, lumped them together so that we could address them. Next, we had our analysts write playbooks for the actions to do on these alerts. And then we reviewed the playbooks for ways that we could automate. What could we take? What steps could we just automate right off in those playbooks? And through that automation, we were able to reduce alerts. So this one is about as simple as can be. Using Splunk, we just used a simple count command. So we just did a stats count by alert type, and we were able to see which was our largest volume, where the largest volume alerts were coming through. And those were the ones we wanted to focus on first. And so that's what we did. We got our most commonly occurring alerts, and then we go to step 2. And that is we wrote playbook alerts by the count of the alert. So the first thing we did is we put those alerts in front of our SOC analysts and said, what would you do? How would you resolve this? And one of the things we came back from is this became our mantra. If SOC analysts cannot create a meaningful action, the alert needs to be silenced. There is no point in sending alerts in that you can do nothing about. And there may be many reasons why you can't do anything meaningful with those actions. Examples may be someone turned on all the informational alerts. You know what, that's cool, but there's a reason they're called information instead of, they're not high, medium, and low criticality. They are informational. And it is difficult to do stuff with those. And so we started turning those off. Other things we did, I doubt we're different than anyone else. Separation of duties says your SOC analyst and your system admin are not the same person. And so when we get configuration issues coming in, that a system might be misconfigured, our SOC analyst can't do anything. Why do we need to fill their inbox with alerts for changing system configurations? Those should go straight to the system admins where they can actually be covered. So those were, we took care of that. Another one, sometimes the alerts just aren't relevant to the network or the node. It is really cool that you're getting an SMTP buffer attack on server X. But you know what? If server X isn't a SMTP server, it doesn't matter. It's not going to happen. Nothing's going to occur. And if you're going to just go do the attempt of, well, I will block every firewall on the firewall, every malicious act on my network, you're pretty much just playing whack-a-mole with IP addresses. And so we really just said, you know what, we're just not going to fire those alerts off to our SOC. If it can't hit our infrastructure, let's not alert our SOC analysts on it. And it's a discussion for another day, but the information we get from the Corelight sensor allowed us to build inventory, so we could actually, using our inventory, we knew that IPX was an SMTP server or IPY was a web server, and what kind of ports it had open and what software was running on it. And so we leveraged that technology to make our alerts more relevant. And so here's an example of our playbook, and it's data obfuscation. You'll see we have a T1001, T1048. Those are tied to the tactics and the MITRE, and they're pretty much the same concept. Is the bad guy using a port that to exfiltrate data. And so what does an analyst need to know? And the first two boxes here is, what is the port normally used for? What is the service that runs on that port? And then we need to know, is the source or destination IP an external IP address? There's a difference in risk if it's going external or whether it's staying internal. Another thing, how many bytes of data is coming in, how much is going out? That might be a good indication of exfiltration. The second line of events here is a lot more of the knowledge that an analyst needs to know how risky this is. And that would be, how many external IP addresses is this IP address talking to? How many internal IP addresses? How many external addresses are trying to communicate to it? How much traffic is going on in the subnet of that source IP? And we call it threat hunting, but it's basically the concept of alerts. Are there other alerts or events that are associated with this IP? And so we wanted to put all that data there into the ticket, and if that information was available, the analyst could make those decisions. And so we looked for ways to automate. And the first thing we know is we got a lot of tier 1 analysts looking at this ticket, and they don't have every port memorized. You know what? Some of your tier 2, tier 3 analysts don't memorize every port. And if they don't have those ports memorized and the service that runs on them, they're going to have to look it up. Google's a great tool, but it takes time to go Google all those addresses, all those ports and services. And so we realized, you know what? If we used an automated lookup, we could actually just tie into the ticket that's being sent in what is the port typically used for, and what's the typical use of what service runs on that port. And the nice thing is, the Corelight app that you can find on Splunk base, it actually had that lookup already built into it. No reason to reinvent the wheel. And so we did rename it so that we wouldn't have naming conflicts, but we created a lookup called port DESC, and all of our tickets now have that information just added onto it. Next thing we do is, I call it the generic bucket called the domain reputation tools. Every place has it. It varies slightly, but the concept is the same. You have a domain that your machine is contacting. You need to know whether that's a known malicious domain or not. So you'll use your Alexa 1 million, you'll use domain tools, you use whois, and there might be, depending on the organization, a bunch of other different sources. And we had our own process there, but for the analysts to go in and look up each one of those in our different tools, that was a time-consuming process. So we leveraged Phantom within Splunk to do that work for us. So this right here is a Phantom playbook. You install Phantom, you will automatically get this playbook. we didn't even have to modify anything. At the start box, in comes your alert. It goes into Phantom, and it goes into 3 different lanes. The first lane is called the hunt domain, and it basically does your Alexa 1 million, your whois, your domain tools. If you have other tools you use, it's as simple as putting in the API connection into Phantom and adding it to that node. And it will then, when the alert comes in, it'll automatically do all that lookup for you and then append that information to your ticket in that investigate node and send it on its way. Lane 2 is hunt file. So if your alert comes in and it's got a hash in there, it can go against your virus totals, your built-in AV engines, whatever you're using to do file reputation. And it will then, depending on what you've determined as your file reputation riskiness, it can actually go and grab the PCAP file and go and detonate the file if you have a detonation chamber. And all of that done without an analyst needing to do a thing. The last line, this one's been a lot of fun for us, is run the query. If there's a query in there, such as in the URI field in your web logs, it will look for, hey, do I see SQL injection going on in there? Do I see cross-site scripting going on there? Do I see command lines being run, bash commands, anything along those lines that might be considered suspicious? And it will pull that stuff out using some regex and some other logic, pull it out and add it to your ticket. And what's really cool about this is we talk about you got to get that data in somehow. Corelight provided us all those fields we needed. In order to be able to do a hunt domain, you need a DNS, you need a domain name. The Corelight DNS source type provided that for us. In order to do MD5, SHA, whatever you want to call it, file reputation, you need the hashes, and Corelight Files already holds all the hashes for every file passed across the network. In order to do queries, you're going to need the URI field. Corelight HTTP already holds that for you, so it pulls it all apart. Another really cool feature is Corelight works really well with full packet capture. The packet capture has a community ID, and Corelight will store the logs it's pulling that are associated with that community ID. And so using Splunk, you can use a drill down, click the community ID, and it can go to a system like Moloch or something and pull back the packet capture directly related to that Corelight event. It's a really cool feature, has saved us massive amounts of time. Other things we did, if we go down to the traffic to external internet IP addresses, we use Splunk to build dashboards. We used to have our analysts go and they'd do manual lookups and go query through all the data when they saw something suspicious to add more intel to it. We realized we could use automatic Splunk magic and build drill downs to just show that information. So when our analyst gets a ticket, they click on the IP address and they're taken to this dashboard. This dashboard gives a heartbeat concept, so you can see a potential command and control structure. That very first IP address, that's a potential heartbeat going on there. It looks pretty regular. You can see some irregular connections. The second dashboard is potential exfil, and you can see how many bytes were sent out to the to different IP addresses. And we also have in there machines being contacted by the lookup machine, machines contacting the lookup machine. This happens to be a web server in this example, so web traffic came back. So we can see what machines are accessing our web server, what are the status codes that are being thrown. And another one we really have been having fun with is user agents. Yes, we realize that people can spoof user agent strings, but it is amazing how many people don't. And so we can go look at the user agents and look at those strange user agents contacting our machines and doing stuff with them. And so we provide all that information to our analysts. And so our new alert ticket looks a lot like this. Originally, we just had the first four, the source IP, destination IP, port used, service used, with some timestamp. Now we've been able to add in, hey, what was the common usage of that port? What's the common service being used? What did the web reputation come back on it? Was there any URI queries that were found in that ticket? Were there any files attached? And then, as we said, here's your dashboard information, external IPs being contacted, external IPs reaching into the network, and internal connections over the last 7 days. And so our tickets have vastly improved. And so the analysts can look at this and make a decision much faster than they used to be able to do. So what's happened? We've attempted to automate. We've written out our playbooks, attempted automation. So what have we seen? I'm calling it miracles. Here's a timeline from November to May. And in November, each analyst was receiving approximately 2,000 alerts. And that continued to creep up until March, where we were hitting approximately 6,000 alerts per day. And in April, that dropped in half. And in May, it's down to approximately 500 alerts an analyst is receiving. That's still well higher than the 20 we want, but it is growing down. And the month of June is looking even better. We are down about half of that again. But what's really impressive is it's not just about the fact that we're reducing the amount of alerts that are coming to our analysts. If you look at that red bar on the chart, it's our custom alerts. Our SOC 1, our tier 2, tier 3 analysts, as they are looking through things, investigating things, they are creating new searches that are more tailored to the environments we're looking at. They're more ICS focused because that's where our environment is. And they tend to relate a lot to what's going on in that area, and versus your generic cookie cutter alerts. And so that number is continuing to increase while the number of alerts that we actually get is coming down, which means the amount of fidelity to our alerts is drastically improving. Instead of having thousands and thousands of tickets come in each day and almost none of them containing anything that's actionable or useful, we actually have stuff that we're seeing now. We're able to provide customers insight into their network, things that they need to look at, things they need to be concerned about, things that are going well, where it's been really impressive to watch happen. We've been able to provide a lot more value to our customers. And I'm now going to turn it over to Wissam.
Thank you, Troy. Yeah, this is awesome. The way you told the story, the before and after, right? Before doing on manual stuff and after doing the automation, how much you save time. So I'm just going to talk about how you can get started today. Your next steps is to get started today with ingesting the data into Splunk for analytics from Corelight. So for that, you need the Corelight app, which you can download for free on our Splunk base, which is our app marketplace. To do the playbooks using some of the Corelight data and the playbooks with Splunk, there's the Corelight app for Splunk Phantom. Phantom itself, the security automation orchestration, the SOAR platform, is available for free on phantom.us. And those playbooks that Troy showed you and some of the community playbooks, you can download them also for free and make some changes and modifications for your environment, also on phantom.us. And all these are available today for you to get started.